All right. Good morning to the folks joining us from Austin, Texas, and good afternoon, good evening to the people joining virtually. I am Bhargav, and with my co-colleague Debasis, we will be presenting on our topic, investigating a WSA endpoint. I am Bhargav. I work as a security analyst at CSERT Salesforce. I also serve as the organizing committee member for DFIR's USA and APEC conferences, and my interest areas are DFIR and malware analysis. I would hand it over to my co-presenter now.
Hi to all, I am Debasis. I'm the security researcher at Cyber PWN, and my interest areas are digital foreign DFIR, malware analysis, and cloud security. We acknowledge and thanks School of Information Technology, Artificial Intelligence, and Cybersecurity of Rashtriya Raksha University, giving us the opportunity for doing the research work. This is our agenda of our presentations. You might be wondering about what is WSA. Windows subsystem for Android is the second subsystem after launched Windows subsystem for Linux in Windows 11 OS. It supports execution of Android native applications in Windows 11 operating system. And it is the first GUI based subsystems. And also it runs inside Hyper-V virtual machines.
All right, some of you might be wondering why we chose WSA as our research topic, right? So we chose this as this was launched in 2021. So it was launched by Microsoft in 2021 in the beta version of Windows 11 systems. So initially, this project was started as a fun side project and an exploration project. So basically, I wanted to play games, Android games on a Windows system. But I had used Android emulators like BlueStacks earlier, but they are quite slow and not very good when it comes to playing games. And this WSA allows native Android applications that you can use it on your Windows 11 host systems. And there is not much document when it was released by Microsoft side, and no one from DFIR was talking about this at that time. So, and it has its offensive use cases as well. So that's our journey towards starting our work on WSA. I would hand it over to my colleague now.
Let's look at the WSA timeline. It was first introduced in beta version, then subsequently release preview, dev, and stable versions of Windows 11 OS. Look at the WSA requirements of Windows 11 OS. As I previously told, WSA runs inside the Hyper-V virtual machines. Let's see their VM lifecycle. There are three possible states. First one, running. Second one, does. Third one is not running. These actions are triggered when user activity, Android app being run or closed, and an app notifications. Android app paused and stopped when their Windows is minimized. You might wonder about how to install Android applications in WSA. It can be done via 3 ways. First, via Amazon App Store. It was developed by Amazon's when WSA released to Windows 11. Second, via SDK DB. There is side-loading Android applications runs via ADB. In order to do so, installing the APK that can be downloaded from any website. Third, via WSA tools. It offers a GUI version and works via ADB. Due to restrictions of Amazon App Store in India region, we used WSA tools for our research work. What's happened when you install an APK on Windows 11? When you install the APK file in Windows 11 OS, a LNK file, shortcut file created, and that links to WSA client.exe. Look at the screenshots. These are screenshots.
Right, so many of the folks must be wondering what is the difference between an Android and the Windows subsystem for Android. So I've noted down some of the key differences between an Android device and WSA. So as you might know, Android device is a physical device which is capable of running Android OS, whereas WSA is a virtualized environment and it runs inside a Hyper-V virtual machine. As this is a physical device, there is no emulation needed on an Android device, but WSA emulates some aspects of Android device. So Android device, from the point of GUI, it is a true GUI. So you can, like, it provides the graphical user interface in order to interact with the application or the OS, whereas WSA is not a true GUI, although it is a GUI-based subsystem. It does not offer all the GUI features of a Android device. Android devices generally are inbuilt with Google Play Store installed by default to install the Android applications, whereas in WSA you get Amazon App Store, where you can download and install any of the Android applications. Android device is tightly integrated with Google services, as you might know, as it is developed by Google, whereas WSA, it is a subsystem and it offers an integration between the Windows services and features. So it provides a cohesive experience if you are using WSA, and this is WSA is developed and rolled out by Microsoft. So, and Android device is specifically run on like wide variety of hardware, from smartphones to tablets, smart TVs, and other devices as well. Whereas WSA is primarily intended for Windows OS-based desktops and laptop computers, specifically for Windows 11 as of now. So on an Android device, you are able to send SMS or text message and receive voice call, whereas on WSA, there is no such feature. Essentially, there is no SIM or eSIM inside the WSA, and WSA utilizes the network connection of your Windows host machine, that is Windows 11 in this case. All right, time to investigate a WSA endpoint now. So what all digital artifacts are generated due to usage of WSA? So there are basically two types of artifacts. The artifacts are present on disk and artifacts are present on memory. So the artifacts present on disk can be categorized into two categories: Windows-specific artifacts and WSA-specific artifacts. And in WSA artifacts, you can see the Android debug logs and all the other registry related to WSA when you install an Android application. So the first Windows artifact is the timeline artifact. It is present in the activities cache.db file. And it provides us with the information about what WSA package was launched. As you can see in the screenshot, there are, you can see com.android.contacts, com.android.document.sui, and com.whatsapp. So com.whatsapp is what appears when you install a WhatsApp APK on a Windows 11 system. So once you install it and run it, it will give you this event where you can see it has the platform as Windows 32. That means this is the installed application. And subsequently, the com.android.contacts and com.android.document.sui. So these two features are inbuilt in the WSA. So I manually launched, so document android.docu.sui is showing us exe path. So this is the settings of Android, which I opened it inside WSA and it got noted here. So it has the platform as exe path. So whatever you run inside your WSA, inside the application, it will be shown as the platform as exe path here. The second artifact is prefetch. So prefetch is, it gives various details, and the details are system name, application execution time, last execution time, and the file path. And in the case of WSA, you can see these 6 EXEs that you can find it in prefetch data. And if these are present, you can definitely say that this was WSA. The third artifact is the shortcut or LNK file. So shortcut.lnk file will be located in the start menu and programs. So whenever you install any Android applications on WSA, it generates a shortcut file and it will be visible on the start menu. And you can find it here, and you can find it what is the target file here, like target location. So these two shortcut files are pointing to WSA client.exe, which is run. So whenever you double click or execute this, it will point to WSA client.exe and it will run the subsequent application. So Amazon App Store is installed by default when you install WSA. So yeah, and moving forward, as a system resource utilization management artifact. So this gives a brief idea what application was run. It also gives the network usage view, what inbound and outbound bytes were sent or received. So it will always have WSA value. So whatever applications you have, it will have that at the start and app WSA client.exe. And it can be viewed with the Zimmerman's tool, some TCMD. The next artifact is the Windows Defender logs. So you might be wondering why Windows Defender logs are present or we should be looking at Windows Defender logs while investigating WSA. So Recently, Microsoft launched Defender inbuilt with WSA, so you cannot install any of the malicious applications. It will be auto-blocked by Windows Defender and it will be quarantined. So this is a very important artifact if you're checking for any of the malicious application installed. So the Defender logs give us what action was performed, what is the file name, and what is the description. So in our case, the source was mpcmd run. So mpcmd run, it contains all the information that is used to manage Defender. And these are the loggings of Windows Defender, but we can find the specific, if it's an Android one, then we can specifically find it in Defender logs as well. Moving on. So let's put on our Hamza suit. This is Windows as Windows Registry is a very complex artifact to look in. So just a precaution. So the first registry that we see is user assist. So it gives the, you can determine that what was launched in the, Windows 11. So it will have the value of whatever application settings app. Then comes the amcache. So amcache will provide with the package name and the WSA related applications. Then the recent files. So what was recently run, what applications the user has run on the machine, then applications installed. So once you install any of the applications, it creates a registry in the name of the applications that you have installed. So in this case, it is Chrome, but in the registry, you will find as it has an alphanumeric value embedded with WSA dot. It will be some alphanumeric value here, and it will have this Chrome identifier. So you can identify this is WSA Chrome and not the Windows Chrome that you use on a host system. Then URL associations. So this will give us the detail what program opened a particular URL. So in this case, this is related to WhatsApp. This is related to Telegram. So inside Telegram, we had tested for the channels and the groups and the chats. So once we click that, what opens? So that is, maintained here. Then comes the cloud store settings and application metadata. So this cloud settings is the default user account on your computer, and it will have the logging or the event. So here it is WhatsApp. And so whatever applications you have installed, if this is it will have a cloud account associated with it, and the values you can see if it is a default account, the sync is enabled or not. So it will have its logging here. Then comes the notification. The notification settings is for the installed applications and usually displayed in the notification area on Windows 11. So here, this is related to WhatsApp. So you can see if we have allowed senders, like you can mute it, but if you have not, then you can see in this registry what all senders that you have allowed for notifications. Then comes the push notifications. So this is sent to the device by the cloud-based service. So once the notification comes into WhatsApp, then it will push into the Windows notification area. So these both are correlated here. Moving on, we come to the WSA-specific artifacts. And the first one is the installed application icons. So it is located and it will be located in the local packages and the Windows subsystem for Android and this version in the local state. So it has two values. .ico.png. As you can see here, it was installed as like WhatsApp and Amazon App Store were installed. So you will see two icons of each of the applications. Then comes the app compatibility database and language list for populated apps. So if you have installed any of the applications, if you look at this folder, you will have a better idea that what applications are installed on a Windows subsystem for Android. So app compatibility database is maintained because we are running Android applications on a Windows system. So, and the Windows, like Android application, it is translating Android APIs to Windows APIs. So all of those details are maintained in this app compat database. Then language list for populated apps. So whatever apps we have installed, we will have a default or whatever we selected while installing that application, that language is populated here. So for our purpose, we had selected English US. So that's why it is showing us just one here. The second and the most interesting artifact for WSA is these 6 files. The first is metadata and the user data. So these two are the VHDX file or the Hyper-V. These both are the Hyper-V VM files, and all the data is stored in this two main hard drives. Then the system image, system extension, vendor, and product. So these last 4 image files are Android files. So metadata will have all the data stored, whatever applications were installed on it, the metadata related to it, and the data would be in the user data. The system image contains the Android OS basically. Then system extension it will contain some additional system files essential for running the Android operating system. The vendor image, it contains the device specific firmware files, and the product image file will contain the product specific firmware. So these are some interesting files to look for, and it will be located at this location. As you can see, these are the contents inside that folder. So here you can see metadata, hard disk, product.img, system.img, user data.img, vendor dot, and system extensions.img. The third most important is the Android diagnostics log. So it will be present on your system under the same folder, and it has these 3 folders called ETW, logcat, and ANR. So these are Android specific logs, which are generated and maintained on a Windows 11 system on your hard drive. So it gives details about these process events, thread events, file system events, network events, and all those stuff. So ETW is event tracing for Windows, and it is automatically generated by WSA. The logcat is the system messages and the messages that you have written from your app. And the ANR, so if an app is not responding, it will create its log inside this .ANR, and I mean ANR folder, and it will have this like log.ANR extension for this one. This also can be used for troubleshooting your applications, if any. The last screenshot is for the logcat. So inside here, you can see that installer package is installed, like package verification receiver. So this event is specific for when we try to install WhatsApp here. So here you can see integrity rules are not available, and then integrity check passed for WhatsApp. So it will have all the details in the logcat, Then comes the other artifact for WSA settings. So whatever settings you have set it up or configured for this, you can see it here. And you can see if the developer mode was enabled or last execution time and the VM lifecycle and all those stuff. So these two folders, like these two files, roaming.log, will have the PIN or the password that your user has set up. So in WSA, there is no passcode or such. So it is of 0 KB, and the settings.dat file, it has all the settings. So it will show if the developer mode is enabled or not, and so on. So let's come to the challenges for investigating this. So what if the WSA was uninstalled, right? So if you uninstall WSA, then all the associated Android applications are uninstalled. And it will uninstall the Amazon App Store as well. We were not able to perform the uninstallation of Android App Store. So, and we did not install any of the apps through Amazon App Store, so we could not do it. But as per Microsoft, this is possible. So if you uninstall the Android Amazon App Store, it will uninstall any applications that you have installed. And yeah. The second scenario is what if WSA and applications are uninstalled and installed again. So once you are uninstalling and installing it again, in our case, we uninstalled and installed Telegram, so it won't be opened as it was deleted. The data is not present there. But the only artifact that you will find is the registry. Then comes the third scenario for memory forensics. So this is the preview from the task manager. So once you run any of the Android applications, it will open up these many things or the processes and not a single process. So it follows a PICO process based memory allocation and not the traditional memory process allocation. So it is similar to WSL as this runs on a Linux kernel. Then comes the fourth one. How do we extract the data from Hyper-V virtual machines, right? So if you have the system in the possession, so you can run ADB commands and you can find it out what all details are, the configurations of Android has been done there. So these are some of the commands that we ran, and we got the following command outputs. So you can, list all the packages installed, all the third-party applications installed. Here, so here the third-party applications was WhatsApp, and it has this uname. So this is the kernel, Linux kernel that is installed there. And this is running on Android 13. Moving forward. So in the WSA utilizes file-based warning, file-based encryption. So it is enabled by default there. And it is stored in the metadata partition. So we have to analyze the user data.dx file. And this can be done via 3 ways. So you can, see it from the ADB, and you can access the WSA developer configured interface, and you can additionally set up the SMB server via the Windows File Explorer here. So how do you extract artifacts? So currently no commercial or open source application tools are available who can extract or pass this WSA related artifacts. Only the crawl cape is capable, although not all, but some of the artifacts are extracted if you use cape. Then comes the sixth scenario. What if you want to create an image of the WSA, like you create with your normal Android device? So ADB backup and restore is not functional, and it is not functioning as it should here. So we used WSA tools here to extract the backup. So it creates a backup with the WSA backup here, and you can load and load. So this can be, used as a plug and play backup file. You can plug it anywhere and you can use your Android applications from there. So, scenario 7. So what do you look if you have a live system running WSA? So this is the console of the WSA. It has systems, apps, and Android advanced settings here. So as you can see, all these details, you can check if you have the physical position of the system. So this is the Android file manager for the WSA. So it can be only accessed by the console. This is the application installed. You can see it in the apps section here. You can enable the developer mode here. You can even uninstall or force stop or give the permissions, remove the permissions from here. So coming to the end, can WSA be used for nefarious purposes? Yes, it can be, but with very limited functionality due to the increased security features rolling out to WSA. So more testing is required here. So these are some of the ways that it can be used for nefarious purposes. So you can essentially push the applications, via ADB to avoid the detection from Defender, and you can infect the WSA instead of Windows 11. Then you can enable the experimental feature for file sharing. So currently the data transfer is unidirectional, but it can be used if the SMB is created, then you can do it bidirectionally. Then you can embed a malicious applications with a legit one and then install it. And the fifth one is making and installing a custom WSA. So you can essentially you can modify these 4 files and then install your WSA for malicious purposes and backup and restore, as I previously discussed. So what are the limitations here? So the limitations is commercial applications are not able to extract and parse this data. And the Amazon App Store is currently unavailable for India region. So these are the 2 limitations that we had. Then the future work. So we are going to test the exploits on Android OS with the known spyware custom exploits and payloads using Metasploit and the analysis of memory artifacts, which we have excluded from this presentations as of now. And these are the few references that we used for our work. And that's all. Thank you.